to the massive earthquake that woke up Alaska.
Now breaking news, a powerful earthquake has struck southern Alaska, triggering a tsunami warning.
2025 is shaping up to be a year when the ground beneath our feet and the oceans off our shores have never felt more unstable. Scientists are sounding the alarm about a chain of islands where tectonic forces have gathered strength for centuries, the Aleutian Subduction Zone. In recent months, warnings have emerged from labs, universities, and field stations like a rising tide. Some experts are discussing scenarios involving a potential 1,000-foot tall mega tsunami.
So let's get to that breaking news. Parts of southern Alaska, including the peninsula, under a tsunami advisory after a massive 7.5 earthquake rattled the area this afternoon.
A wall of water so immense it could wipe coastal communities off the map. Far from hyperbole, recent seismic data shows 8 earthquakes greater than magnitude 5 striking the Andreanof Islands in just the last 48 hours, rattling the western Aleutian archipelago with relentless force. At meetings like the U.S. Geological Survey's Subduction Zone Science Conference, held this January at the University of Washington, researchers have been carefully reviewing seismic records, volcanic clues, and tsunami debris. There is discussion of massive underwater landslides, powerful enough to disturb vast stretches of the Pacific. Below the surface, mysterious volcanoes are reportedly showing increased signs of activity, with some researchers cautioning that an eruption may not be years away, but possibly mere months. Meanwhile, new research points to the possibility that a catastrophic event could occasionally come with little to no warning. A situation where Alaska's and America's Pacific Rim might be dramatically altered in a single, devastating instant. What's fueling all this concern? Are we on the brink of a disaster so colossal it nearly defies imagination? And will the Aleutian Subduction Zone reveal its true power within our lifetimes? Earthquake storms and the awakening of the Aleutian chain. What sets the Aleutian Subduction Zone apart is not just its raw power, but its silence between catastrophes. The tectonic plates here don't scream, they strain and grind in slow motion, building up energy over decades, even centuries, before letting loose in devastating bursts. The 2025 seismic swarm has put this quiet threat back in the global spotlight, forcing scientists to ask, is this the region's tectonic heartbeat quickening? Or is it the final breath before the rupture? The 8 recent earthquakes weren't just close in magnitude, they occurred in tight spatial clusters, suggesting stress transfer along a shared fault segment. When seismic energy accumulates unevenly and adjacent areas rupture in quick succession, the likelihood of a larger event rises sharply. This phenomenon, known as cascading failure, was one of the early warning signs before the 2011 Tohoku earthquake in Japan, which unleashed a tsunami that devastated entire towns and crippled a nuclear facility.
Now breaking news, a powerful earthquake has struck southern Alaska, triggering a tsunami warning. According to the USGS, the 7.5 magnitude earthquake struck off Sandpoint, Alaska.
In the Aleutians, the stakes are similar, even if the population density is lower. Adak and Atka, small communities with deep-rooted indigenous cultures and strategic military histories, have limited infrastructure and even more limited escape routes. A major quake could cut off communications, collapse vital docks, and trigger undersea landslides that amplify tsunami waves. Unlike mainland cities with vast emergency systems, island communities have to rely on local knowledge, quick decisions, and often minutes, not hours, to get to safety. Even more concerning are the implications for the wider Pacific. Historical data shows that major events along the Aleutian Arc can displace vast volumes of water, sending tsunami waves racing across the ocean at jetliner speeds. California, Oregon, Hawaii, and even as far as Japan and New Zealand could face impacts within hours of a rupture. In 2025, Tsunami Watch centers across the Pacific Rim are quietly updating risk scenarios based on this new swarm activity, while naval bases and ports quietly rehearse blackout drills. The question that now looms large is not just if a major quake is coming, but when, and whether we'll recognize its footsteps in time. The Earth rarely offers warnings in plain language, but its patterns are written in tremors. As the Aleutians continue to shake, scientists and communities alike are racing to decode what could be the last hints before nature's next great upheaval. What makes the Aleutians uniquely dangerous is the combination of steep island topography, active volcanism, and tectonic instability. These elements converge to create perfect conditions for large-scale slope failures, where entire sections of undersea mountain or volcanic flank can collapse into the deep ocean basin. When this happens, the energy released is astronomical. Ocean water doesn't flow calmly around the disturbance. It heaves upward and outward in massive surges, creating tsunamis that can reach terrifying heights before crashing onto distant shores. In the Aleutian Islands, many volcanoes, such as Mount Cleveland, Mount Shishaldin, and Mount Okmok, rise steeply from the ocean floor. Their slopes, composed of loose volcanic rock and ash, are particularly vulnerable to sudden collapse, especially when shaken by a powerful earthquake. Submarine landslide scars, essentially underwater cliffs, have been discovered on the seafloor around these volcanoes, some stretching for miles, suggesting that massive chunks of earth have broken off and plunged into the abyss before. Satellite altimetry, which measures sea surface anomalies, combined with sonar mapping and seismic reflection profiles, has helped scientists visualize these hidden hazards in greater detail. Some of these slide scars are geologically recent, just hundreds to a few thousand years old, implying that the risk isn't just ancient history, but a continuing threat. And the threat isn't theoretical. In 2017, a large landslide near the Ton Fjord in Alaska created a wave nearly 600 feet high, caught on satellite, and later confirmed by field researchers. That event happened in a sparsely populated area. A similar event in the Aleutians, closer to major shipping lanes or during peak fishing season, could be far more devastating. As science advances, so too must public awareness. The invisible monster of mega tsunamis isn't just myth or distant possibility. It's a low-frequency, high-impact event that demands attention. The oceans hold their secrets well, but every tremor, every slope scan, every anomaly is a whisper of what could come roaring out of the depths. Volcanoes stirring beneath the surface, the unpredictable wild card. What lies beneath the Aleutian seabed is not just rock and pressure. It's a cauldron of molten complexity. Beneath thousands of feet of frigid ocean, a chain of active and dormant submarine volcanoes quietly brews beneath the surface. In 2025, that quiet has been replaced with troubling signs of unrest. Seismic sensors have picked up clusters of low-frequency tremors, often the first indication that magma is on the move. Remote-operated vehicles deployed by NOAA and the Alaska Volcano Observatory have confirmed rising temperatures at hydrothermal vents, bursts of volcanic gas, and new fissures along the caldera walls of one of the Ark's lesser-known giants. While submarine eruptions often go unnoticed by the public, their effects can be profound. In confined spaces or shallow waters, even relatively modest eruptions can send shockwaves through the ocean, destabilize adjacent slopes, or displace water volumes large enough to initiate tsunami waves. In extreme cases, if a volcanic edifice collapses, as has happened at places like Santorini or Krakatoa, the resulting landslide into the ocean can generate waves hundreds of feet high, radiating devastation across coastlines. In the Aleutians, the danger is compounded by the landscape's volatility. The islands themselves are the summits of enormous volcanoes that stretch far below sea level. Some are known: Mount Cleveland, Bogoslav, and the undersea Davidson Seamount, but others remain unnamed and under-monitored. These volcanoes don't erupt in isolation. Their geological neighborhood includes tectonic boundaries, landslide-prone slopes, and sediment-laden flanks that can shift violently if disturbed. A volcanic eruption here isn't just a single event. It's a potential catalyst for cascading disasters, slope collapse, seabed rupture, seafloor uplift, and tectonic release. The multi-hazard nature of this environment is what alarms scientists the most. In 1996, an undersea volcanic eruption off Japan's Izu Islands triggered a small landslide that briefly disrupted local currents and sent minor waves into nearby harbors. But in the Aleutians, where underwater topography is steeper and seismic energy more concentrated, a similar event could have exponentially larger effects. Researchers are now modeling worst-case scenarios, eruptions that coincide with major seismic activity, triggering undersea avalanches that ripple across the ocean in minutes. Complicating matters further is the lack of historical precedent. While land-based volcanoes leave behind obvious clues, ash layers, lava flows, crater scars, submarine volcanoes hide their stories beneath the sea. Only with modern sonar mapping, satellite altimetry, and deep-sea drones have we begun to piece together the eruptive history of these underwater giants. Early evidence suggests that past submarine eruptions in the Aleutian chain may have played roles in unexplained tsunami deposits found on distant shores. In 2025, a new sense of urgency surrounds the monitoring of these undersea threats. As robotic surveys continue and seismic anomalies pile up, yet holds the power to reshape the Pacific Rim. Because in this hidden underworld, one eruption can be the first tremor of a far larger awakening. Silent signals. Can we predict the unthinkable? For years, experts believed that major earthquakes and volcanic eruptions would strike with little or no warning. Today, advances in monitoring offer hope that silent signals, low-level tectonic unrest, could provide precious notice ahead of disaster. Across the Aleutians, scientists are deploying an arsenal of sensors: GPS beacons, tilt meters, ocean bottom seismometers, and pressure sensors. These tools track every subtle movement: slow shifts in the crust, swarms of miniature earthquakes, rises and falls in volcanic slopes, and abnormal ocean floor changes. Researchers now know that certain seismic precursors, microquakes, creeping landslides, inexplicable rumblings, there is optimism that similar methods could apply to Alaska's dynamic coast. However, the situation remains deeply uncertain. Many earthquakes strike without clear warning signals, and the complexity of interacting geological events means that distinguishing harmless background noise from genuine danger is an immense challenge. This year's rash of Andreanof Island earthquakes fits some precursory patterns, but does not provide clear answers. Despite the uncertainties, the hope of even a few days' warning drives investments in basic research and public preparedness. But the most sobering possibility remains that our technology and knowledge, while growing, might not always outpace the Earth's most violent surprises. Meetings of minds, urgency at the USGS Subduction Zone Science Summit. In January 2025, at the University of Washington, scientists from across the country gathered for the U.S. Geological Survey's Subduction Zone Science Meeting. The agenda was urgent: new Aleutian earthquake clusters, heightened volcanic tremors, and fresh data on submarine landslides. Researchers, geographers, and emergency planners analyzed maps, models, and centuries-old tsunami deposits. The discussions were anything but academic. Panels focused on how to interpret the recent Aleutian earthquake sequence, the reliability of current tsunami warning systems, and what more can be done to reduce risk for at-risk Alaskan communities. Experts shared findings from field surveys and updated hazard models, emphasizing both recent threats and lessons drawn from ancient disasters. In side sessions, scientists debated evacuation protocols, the effectiveness of seismic chatter as a warning, and the persistent challenge of convincing vulnerable populations to react quickly when danger looms. There was frank talk about the tragic lessons from past tsunamis, the missed signals and communication breakdown. Uncertainty about timing remains, but the consensus is sobering. The Aleutian Subduction Zone is one of Earth's most hazardous, and vigilance, research, and education are the only ways to mitigate its dangers. As researchers left the summit, the weight of the Pacific Coast's future, stretching from Anchorage to Seattle, felt tied to the relentless need to decipher Aleutian warning signs before they become tragic history. Lessons from prehistoric destruction, clues hidden in the Pacific. While cutting-edge monitoring tries to anticipate new disasters, some of the most powerful lessons come from the geological record. Across the Bering Sea and Pacific Northwest, researchers have scoured coastal landscapes for evidence left by ancient tsunamis. Layers of sand, uprooted trees, and devastated forests embedded far inland. These clues reveal just how immense past events have been. By studying tsunami deposits and marsh soil records, scientists have reconstructed a history of massive prehistoric tsunamis along the Aleutian Arc, some of which rival or surpass the biggest events known in the written record. Core samples dug miles inland contain sudden saltwater deposits mixed with oceanic shells and storm debris, remnants of ancient floods. Using these physical records, combined with modern simulations, scientists have crafted new hazard models. The outlook is sobering. Even with modern early warning networks and reinforced coastal infrastructure, a truly large tsunami could overwhelm defenses across the entire North Pacific, impacting communities from Alaska to California and beyond. Equally troubling is the realization that the calm of the last few decades is deceptive. The Aleutians, like other major subduction zones, alternate between long periods of apparent dormancy and brief, catastrophic releases of energy. Each new sand layer or devastated forest in the geological record serves as a stark warning. What happened in the distant past can, and almost certainly will, happen again, though the timing is impossible to predict. And, with much of the oldest evidence buried under modern development or lost to the sea, the true frequency of such disasters may be underrated. The past continues to whisper caution, if only we will listen. Cascadia, the sister threat. What if both zones release together? It's easy to view the Aleutians as an isolated fault zone, but as 2025 unfolds, researchers are paying renewed attention to another major system, the Cascadia Subduction Zone, stretching from northern California into British Columbia. Cascadia is notorious for its own devastating capabilities. A massive earthquake here could trigger tsunamis, cause months of uplift or subsidence, and alter coastlines on a regional scale. Why worry about Cascadia and the Aleutians together? Because the tectonic plates beneath the region are interconnected in subtle but powerful ways. Evidence from other zones around the globe demonstrates that a large quake in one area can occasionally change stress along nearby plate boundaries, increasing the risk of subsequent earthquakes elsewhere. While precise predictions are impossible, the possibility of stress transfer between major subduction systems is an active area of research. At recent conferences, some scientists have modeled extreme scenarios, a major Aleutian earthquake destabilizing the Cascadia Fault, potentially causing multi-zone events within hours or days of one another. While such chains of disaster are rare, the consequences could be immense, not just in tsunamis, but also in cascading economic and supply chain impacts across the Pacific. In this context, every uptick in activity in Alaska or the Pacific Northwest is cause for heightened scrutiny. Are we entering a period of heightened risk, a supercycle where the biggest faults are approaching their tipping points? Science cannot yet answer with certainty, but the potential is enough to keep geologists alert to every new tremor. The scientific world stands at a crossroads. New technologies and discoveries are improving our odds of surviving the next great disaster. But with a natural world as complex and powerful as Earth's active plate boundaries, uncertainty is always just over the horizon. This year, as research races forward and emergency planners refine strategies, the big questions remain. Will nature offer a warning? Will we recognize the signals in time? Or will the Aleutian Subduction Zone spring its next surprise before anyone can raise the alarm? Let us know. What do you make of the mounting signals from Alaska's volcanic frontier? Are you concerned? Do you trust that science will provide enough warning? Or are we, as some fear, simply passengers on a restless planet? Share your thoughts in the comments below. If this deep dive gave you new perspective about the ground or sea beneath you, give us a thumbs up and pass along the knowledge. And don't forget to subscribe so you're always one step ahead of the next mystery our living Earth still has to reveal. Until next time, stay curious and, perhaps, keep an eye on the tides.